Hello, Pre-Algebra. Today we have a, a special lesson. Today's lesson, I have two types of triangles to share about, and these have a pattern. Now, yesterday we were talking about congruence and similar polygons. Well, these are two types of triangles which which would be similar, you could say that, but they have a particular ratio because of their angles. Yes, they are both right angles, but because of the other angles that they have it gives them a particular ratio for the length of their sides. That's what we want to go over. Now, it will help you so much in geometry moving forward, and even in trigonometry. There's a lot with these special right triangles. Yes, it's a lot, but if you memorize this pattern, boom, it's going to be easy money, okay? The first one that I want to talk about is called a 45-45-90 triangle. Now, we all know that for triangles, the sum of their internal angles, the sum of the interior is 180. 45 plus 45 is 90. 90 plus 90 is 180. So these right triangles look something like this. Let's see, let me do that. Don't worry about this black writing for a second. Let me just show you. Okay, so we've got our right angle. We've got our 45 degrees in the other two corners. And because these open up at the same angle, their length that they open up to is going to be the same. So these are both marked with the variable a. Now, because we have our hypotenuse, we know has to be bigger, and it's always, always, always a times the square root of 2. Now, we can't simplify the square root of 2. So, all we need to remember is that the ratio between the legs and the hypotenuse, the legs are going to equal a. Whatever a might be 1, it might be 7, it might be a billion, right? The legs are going to equal a, and whatever a equals, our hypotenuse is going to be that number a times the square root of 2. So, no matter what, for a 45-45-90 triangle, it's a root 2. Always, always, always. Okay? Here's some examples. Find the length of the hypotenuse of a 45-45-90 triangle whose leg is 3 inches. Now, that's only one of the legs, right? It's singular, it's not plural. So we need to write it out. So in the corners, I wrote the little symbol that our two angles are the same, indicating that it's 45-45-90. We have 3, 3. Well, if we use the ratio, if our variable a equals 3, then our hypotenuse will just be 3 root 2 inches. Again, with the pattern, it really is that simple. It's just plugging some things in and knowing the pattern, knowing the ratio, and solving the example. I've got another one here for you. Find the length of the leg. So we're kind of working backwards now. We're solving for the leg of a 45-45-90 triangle whose hypotenuse is 6 root 2. Well, again, so I drew this a little bit differently, but again, here's my 90-degree angle. Here are my 45-degree angles. If this is 6 root 2, then our legs are going to be just 6, right? I'm just ignoring that root 2 right there. Okay. Hope this makes sense. It really is this straightforward. But if you don't know the pattern, then it's going to be gibberish. You're not going to know, right? You can't just do the Pythagorean theorem if all you know is C, right? Our hypotenuse. If you only know your hypotenuse, well, you can't subtract anything from it to find the missing leg. Okay, this is the first one. The second one is really similar. It's a little bit more difficult. And this is for a 30, 60, 90 triangle. So one of our angles is 30 degrees, then 60, then 90, because it is a right triangle. So with this guy, it looks like so. So here's my 30 degrees. Your 30 degrees will open up to a leg of A. Now your 60 degrees opens up to a leg of A square root of 3. Our hypotenuse is 2A. So it's A root 3, 2A. How I always remembered it is 1, 2, the square root of 3. So I have 1, 2, 3. You just got to remember where they all fall. So here's another thing. The ratio leg 1, right? This is the smaller angle. The smaller angle opens up to the smaller leg. So we have A root 3. These are our two legs. And then our hypotenuse is 2A. Again, that's 2 times A. Something to note. The square root of 3 is about 1.7. I think it's 1.73 or something like that. And, it's a long, it's irrational, so it doesn't have an end. But it's important to know that because you might think, wait, is it the square root of 3 on the hypotenuse or is it 2? You might get these jumbled up. 2 is larger. 2 is larger than the square root of 3. So don't mistake and put the larger number, 3, on the hypotenuse. That's wrong. That's not going to be right. Make sure that you have this ratio down. Okay. All right. Here's an example. Let me use my little... Oh, hold, please. Okay. So here's our example. Now this one's just drawn out for us. We have a 30, 60, 90 triangle. So we know that this ratio is going to be applicable. And our 30 degrees opens up to a length of 4. Solve for x and y. Okay. Well, if I just plug it into this ratio, my hypotenuse is going to be 2 times A. A is 4, so x is going to equal 8. 8 units, right? I took the 2 from the ratio and multiplied my A, which is 4. Okay, now my y is going to be really similar. Y is going to equal A times the square root of 3. Well, A is 4, so y is going to equal 4 root 3. I know it looks ugly, but once you learn the ratios, learn the pattern, man, this is going to be easy stuff for you guys. You guys are going to nail this. Okay, I've got another one. This one's a little bit differently. We're given our 60-degree leg, right? And I mean that because this opens up. This angle separates or opens these two guys, leaving us with this length. Okay. Now I've got 5 root 3. What's my x going to equal? What's my y going to equal? Well, my x, I didn't even write it down. My x is going to equal this coefficient, A. So what's y going to equal? Y is going to equal 2 times A which is 10. Bada bing, bada boom. Might look ugly. Don't be intimidated. Don't be scared. Also, if this is still confusing, please, please, please either comment below or email me, and I'll get to your emails as soon as I can. Otherwise, I look forward to hearing from you guys. Know that I love you very much. Bye.